let's prove existential statements of this form to exist x in D such that Q of x. So because this is an existential statement, how do we show that an existential statement is true? That means just look at its quantifiers. If you are able to find such x so that this is true, then you successfully prove that this statement is true, right? So in other words, you really need to just find it. Always say that this method is so-called constructive proof of existence. Basically, you try to find it so that this statement is true. Now let's take a look at the first example. Prove that there exists an integer, an even integer, and that can be written in two ways as a sum of two prime numbers. So really, you just need to come up with such an even integer, right? So you just trial and error. You begin with just try. So I'm gonna try 10. So let's say 10. Can you find two ways to write 10 as a sum of two prime numbers? Let's give it a try. For instance, 10 is certainly equal to 3 plus 7, which is one way. Both 3 and 7 are prime because for 3, the only way to write a product is 3 times 1. For 7 is 7 times 1 or 1 times 7. So they're both primes. And you can certainly see that 10 is also equal to 5 plus 5. 5 is a prime, so it's sum of two prime numbers, right? Even though it is repeating, but certainly it's two prime numbers. So therefore, this constitutes the proof of this statement. So here, we kind of just give one example, just construct one example to prove this is true. So now, yes, right? So now take a look at the second one. There exists k in Z, so k is an integer, such that 22r plus 18s plus 37 is equal to 2k plus 1. So that means you just try to find k. How about you try to find k? So let k be something. This is what you are trying to find. And then you want to show that 2k plus 1 will get to what's given, right? 22r plus 18s plus 37, that will end up with being 2k plus 1. So what is the k? Actually, you can kind of like on my scratch paper, I'll try to do this. 22r plus 18s plus 36 plus 1. And then I try to rewrite this as a 2k. 2k, that means I try to factor out the 2, which is 11r plus 9s plus 18. So that's what I would call what my k is, right? So let k be 11r plus 9s plus 18. Then do you see that when this happens, when this is my k, then the 2k plus 1 is equal to, then you can do the algebra, which is exactly this guy. Twice of that plus 1. I know this has to be true because I derived that from here. So that's my little proof. That's the proof. Do you see that? This is the proof. We were able to find such an even integer, right? We were able to find such a k. So whenever you find it, you finish your proof.